This is EC286 part C. I'm trying to solve here V of t, which is right here. And in order to make it easy to solve circuits that have mutual inductance, we have to be able to come up with a model that represents the mutual inductance in the way that makes it easier to set up KVL or mesh analysis equations. And the first thing that we have to do here is we have to be able to redraw the circuit. And it looks like this. And we have here induced voltage. And that's because of the mutual inductance. And our second inductor. And another induced voltage. The resistor stays the same, and the current source stays exactly the same way, except that we have to be able to change the numbers from time domain to frequency domain. And if we do, and it's going to be to 0 degree, resistor stays the same way, 10, 50J, and this is going to be 100J. Our resistor stays the same, 20, and our induced voltage for the first one is going to be plus minus, and that's because of the mutual inductance in what happens between the coil and the current in loop 2. And the induced current is going to be downward, and it's going to be I2 50J, and we have here plus minus I1 50J, and the induced current is going to go upward, and that's because of the mutual inductance in what happens between the coil and the current in loop 1. The next step is to set up the equations. So the easiest thing here is I3. I3 is, we don't have to do anything for I3. It's going to be minus 2, 0 degree. But for loop 1 and loop 2, we have to be able to come up with the equations. So for loop 1, it's going to be I1 20 plus 100J minus I2 50J is equal to 0. This will be I2 50J 20 plus 100J, and the equation in loop 2 is going to be like this. $50J I1 minus 10 I3 is equal to 0. And then I2 will be minus 0.331 plus 0.5813. This is 5 here. And finally, V of t is going to be 10 open bracket I3 minus I2 close bracket, and finally the answer is going to be 17.67 and 19.20 degree volts. That's it.